So today we're going to talk about the definite integral. Here's the definition of the definite integral. With a definite integral, we have a closed interval that we are looking at. So we're going to look at some interval from A to B. So A is inclusive and B is inclusive. The formal definition is we are doing Riemann sums, but we're taking the width or the number of rectangles we are making is going to go to infinity. So we're doing Riemann sums. And the definition includes Riemann sums in which the number of rectangles we are having is going to infinity, and which means that my delta x, the change, goes almost to 0. So there's a couple of words that we need to talk about. The f of x that we see right here in the definition, let me see if I can get this to work. This f of x, we call that the integrand. So that's the integrand. That's the thing that we are taking the integral of. So when you see on your homework, find the integrand that would satisfy this or whatever, that is what they're asking you for, is that function that you're actually integrating. And then we're going to do it with respect to x. We're also going to be doing it with respect to other variables. So if you see dx, then we are doing it with respect to x. If you see it with t, then we're doing it with respect to t. If we're doing it with u, then it's going to be with respect to u. So that du is going to help you determine what the variable is and what is considered a constant. All right, so this is what we're going to see. Let me erase that lovely thing there. What we're going to see is the upper limit and the lower limit. So A is on the left side, B is on the right side. A is the lower limit, B is the upper limit. The integrand in, of course, is the f of x, or the function that's given to us. In this particular case, we're doing it with respect to x, so you see dx there. And when we say with respect to x, our variable x is what we are doing it in reference to. And we call it the variable of integration. When we are finding integration, when we're doing the integration, what we're doing is we're finding the area between the curve and the x-axis. So we're finding the area between the curve and the x-axis. So here's an example where I'm doing it with respect to x. Now notice that A is first on all of them. That is my lower limit on all of them. B is the one on the right, so it's second, and it is the one that is on the top of the integration, or the upper limit. And we are always finding the area under the curve when we're integrating at this point. And I say at this point because we're going to find volumes. Not in this class. That'll be calculus too. Yes?
We have three-dimensional graphs at that point.
Yeah. It'll be phenomenally exciting. You're like, That leads us to this. Continuous functions are always integratable. Continuous functions are integratable. So if my function is continuous on that interval, then it is integratable on that interval. These are closed intervals. Closed just means I include the endpoints. That's all it means. Closed intervals just means I include the endpoints. Okay? So if we are asked to find the area, and we're not asked to actually integrate, so be careful in what it's asking you for, and on the homework you're going to see visually they're going to ask you to do it by visual inspection. They're asking us to evaluate it without knowing anything other than the shape of the graph and doing it by geometry. So what you do if they're asking you to do this by geometry is you're going to draw whatever that function is. And you'll notice on these they're all absolute values or they're linear. So all of these you're going to see as linear. So it's going to be a pretty easy shape to find. So if I'm asked to find the shape or the area, then I'm going to graph this. This is just the line y equals 2x plus 4, in which I'm going to start at 4 as my intercept, and then I'm going to have a 2-1 slope. So I'm going to go up 2 and over 1. So it's going to have some kind of shape like this. That's what the graph is going to look like. Now, notice they want us to find the area in which I start at -4 and I end at 2. So I start at -4 and I end at 2. So I have this shape right here, and then I have this shape right here. What are those two shapes?
Right triangles.
They're just right triangles. Not only are they triangles, but they are right triangles. So all I have to do is figure out what the base is and the height. To figure out what the base is, I need to know where this crosses the x-axis, because I know the entire length from one side to the other, from -4 to 2, is 6. But I need to figure out how much of that belongs to the left triangle and how much belongs to the right triangle. So I need to figure out where that crosses the x-axis. So this is heavy algebra. This is not a lot of calculus. This is heavy algebra. So I'm going to set, I have the equation y is equal to 2x plus 4. I'm going to put that so that I have this equal to 0. So I set this equal to 0, and I get 2x plus 4 is equal to 0. That is some nasty looking writing there. My pen's not working, so I'm using my finger, and I'm not doing it very well. So I'm going to subtract 4 from both sides, and then I'm going to divide by 2. So when x is equal to -2, that's when I'm crossing the x-axis. So I know what, if I look at this triangle right here, the left triangle, my left triangle is going to have a distance or a base of 2. The distance from -2 to -4 is 2. Now what I have to do is I have to figure out what my height of my triangle is, and the way I do that is I go into y is equal to 2 multiplied by -4 plus 4. So my y value is equal to what? -4. So the height of this triangle is 4. This is my left triangle. How big is the area of my left triangle? It's 1/2 the base times the height. 4. So this is going to be equal to 4, and then I have to find my right triangle. So please find the right triangle. I found the left triangle, find the right triangle. Here's my right triangle. What was the base of my right triangle? 4. What was the height of my right triangle? So what is the area of this?
16.
Okay. So this, if I add them together, I'm going to get the area under the line to be what?
20.
Okay. Now let's actually do the integration. I'm going to explain something in a minute. Let's do the integration. I'll answer questions in a moment. So if you have questions like what? Well, just a minute. So we're going to go from -4 to 2. And I'm going to integrate 2x plus 4 dx. When I'm integrating this, I add a power to what's there, and then I divide by that power I've added to. So this is going to be equal to, so I'm adding a power, so that's going to be equal to x squared, and then plus 4x. Now, because this is a definite integral, I have these limits from -4 to 2. We're going to plug these values in to the function, so this is going to be equal to 2 squared plus 4 times 2 It's your upper minus your lower. Minus, now I'm going to put in my lower. So I have negative 4 squared plus 4 times 4, negative 4. So I end up with 4 plus 8 minus 0, which is 12. That's not the same answer we got before, and I'll explain why. That is not the same answer as I got before. Before I got 20, yeah? So, as long as I did all of my triangular stuff here, when I am above the x-axis, it's going to be a positive number. If I am below the x-axis, it's going to be a negative number. When we integrate, we are integrating, if we're just asking us for the integration, we are finding the net area. Because we're finding the net area, some of your answers are going to be positive, some of your answers are going to be negative, and some of your answers are going to be 0. That is something different than the total area. So if you're asked for the total area, then we're going to do it by breaking it apart in the above and below parts. So if they want the total area, you have to figure out that crossing point and break apart your integration. If they just want you to find the net, then you just integrate. And you may have negatives and you may have positives. Yes? Question?
Why do we use the on the left triangle? Why do we include it above the line, not below the line?
So when we're doing integration, it is from our function or curve to the x-axis.
Oh, to the x-axis.
To the x-axis. Yes?
So if we just need the total, it's absolute value, and
Yep. So if we need the total, it's the absolute value. Now we must have done we must have done something wrong, because these should have been the same numbers. Minus, if I would have had negative 4 plus 16. Yeah, I got 12. It works. Negative 4 plus 16. So yeah, it works. So pay attention to what they're asking you for. If they want you to just integrate, you just integrate. If they want you to integrate, they're asking you to find the net area. But if they want the total area, you have to figure out where it crosses the x-axis and break this up. So if they wanted the total area, then what I would have had to do is I would have to break it up between negative 4 and negative 2, and then plus negative 2 to 2. So I would have had to break that apart. Whereas this part, because it's below the x-axis, would have been the absolute value of my function dx. And then this side would have just been my function dx. Okay? So if they want the total area, you do the absolute value of the one that's beneath the x-axis. Yes?
What do you have to break that up into this further terms to have the one?
No, so the break apart was, so the question is, do I have to break it apart more? And the answer is no, because it crossed at negative 2, and that's how I break it apart. So anything on the left side of negative 2 is below the x-axis. So I do my regular integration with an absolute value on it. So put an absolute value on that answer.
So you only want to break it apart for the summation, not the integration.
We only break it apart if we want the total area. If they just want us to integrate, they're asking for the net area, which may be negative numbers, positive numbers, or 0. Okay? All right. So let's go down to this. Let me erase this. I didn't charge my pen, and now I'm paying for it. So this is what we're talking about. What we just talked about, here's the definition. When we're asked to integrate, it is the net area. When we want the total area, then we need to do the absolute value of it. So when we are integrating, it is by default the net, which means we're going to have positives and we are going to have negatives. So on A here, or B, what I have to do is I have to determine where, if at all, I'm crossing the x-axis between 1 and 2. If I'm asked for the net area, then I'm just going to integrate. So go ahead and integrate A. Just integrate it. Don't worry about the crossing point. So just integrate. I don't know if this will work or not, because I have to adjust it to my...
We'll see. This should just be the basic stylus.
Yes, I'll give it back to you at the end. Because I pretty much suck using my finger. So if I'm asked to integrate this, then this is going to be equal to, just for integration purposes, this is going to be equal to, it's going to be 2x, 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 look at that, I'm having such problems, minus x squared divided by 2. This is painfully slow. I think I'll go back to my using the finger. So you give something to me that you don't yourself.
I don't know.
All right. And then we're going to integrate from 1 to 3. So we put our 3 in first. We do our upper bound minus our lower bound. And when we put the upper bound in, we're going to get 3 times 2 minus 3 squared divided by 2. And then I'm going to put in my lower bound, so minus, and it's always minus my lower bound. Always minus my lower bound. So it's going to be minus, I'm going to put in 1, so 2 times 1 minus 1 over 2. And when you clean this all up, what'd you all get?
0.
You ended up with 0?
Oh,
Some got 3, some got 0.
got 3 over 2 minus 3 over 2.
3 over 2 minus, oh, you're all going to make me do this, aren't you? So I get 6 minus 9 over 2 minus 2. What? So, okay, well, let me finish. Just let me finish. Okay, we get 6, right? Minus 9 over 2. And then minus 2. And then this becomes plus 1/2. Do we all agree? Because it would pull the negative through. So yes?
So sure?
All right, today's Wednesday. All right, so 6 minus, I'm going to do this the easy way. 6 minus 2 is 4. And then minus 9 halves plus 1/2 gives us 8 halves, so minus 8 halves. Which gives me 4 minus 4, which is 0. Do you all agree that we get 0?
Yes.
Did I make a mistake? Because you know I am sketchy and my finger's not working well. It is not the best pen in the world. Okay, we cool with that? Yes, no?
I got a different answer, but I combined the 2 and the 1/2.
You should still get the same answer though. Let's do it.
I don't know what that.
Okay, so let's do it the other way. Let's go ahead and combine. So when you combine, did you combine the 6 and 9 halves as well?
No.
Okay. So you have 6 minus 9 halves. And then inside you're going to have 2 over 1 is going to be 4 over 4, or 4 over 2. So then it's going to be minus 3 over 2, which gives you... Okay. All right, cool. All right. Properties, here's some properties. Some of this stuff is going to be more important next quarter than it is going to be this quarter. So the first thing is that when we are, oh, I didn't do it by the net. Let's do the net. I was so excited to get the same answer each way. Okay, so let's do the net. So we have to figure out where this thing crosses the x-axis. So we have 2 minus x is equal to 0. So where is this crossing the x-axis? At 2. So I'm going to break this integration up between 1 to 2 of 2 minus x dx. I'm going to take the absolute value of that. And then plus the integral from 1 to 2. 2 to 3 of 2 minus x dx. And we should get a different number. Yes?
Could we do it 2 to 3 and then 1 to 2 first?
Sure.
So you can kind of flip flop.
Yeah. It did. So the question was, would it have mattered if I did 2 to 3 first? Nah, I just usually go from left to right, though. You can go however, whatever method you want. I usually go left to right. And that only is because if I start breaking it up into multiple parts, which we will, then I just go left to right. So I start with the very left and then go to the right. All right, so let's go through this fairly quickly. We know what it integrates into. We know what that is. So it's going to be 2x minus x squared, absolute value from 1 to 2, and then plus 2x minus x squared from 2 to 3. So, and don't forget divide by 2. Got so excited that put the x squared there. And so my first one, I'm going to get 2 multiplied by 2 minus 2 squared over 2 minus, and then in parentheses, I'm going to have 2 minus 1/2. I'm going to take the absolute value of that. And so then I'm going to have the second part, I'm going to do that in blue, so plus, and it's going to be 2 multiplied by 3 minus 3 squared divided by 2 minus 2 multiplied by 2 and then 2 squared over 2 and then whatever that equals. And I'll leave that up for you all to, no, I'm going to leave that all up for you to enjoy. I'm not actually going to do that. So it is my first part right here, and then plus my second part. So the first part is below the x-axis, that's why I take the absolute value of it. And then the second part is above the x-axis, that's why I don't do the absolute value of it. So I break it apart. All right, how are we doing? Okay, cool. Everyone has a chance to write the numbers down in all of its glory. Here's some properties, and some of these properties are not going to be as important this quarter as it will be next quarter for calculus 2. So if I just say from a to b of f of x dx, that if the limits are the same, a to a, in this case from a to a, notice the limits, let me scroll in big, that the limits are the same there, so it's just a dot space, which doesn't have an area underneath it, okay? If I change my limits of integration from a to b to a, I can do that. There's going to be times where you're going to want to do that, but it does give you a negative. So make sure that you put a negative on that integral. I can, and this is going to be more important next quarter than it is going to be this quarter, is break this apart. So if I have two separate functions, I can integrate each piece individually, each function individually, keeping, of course, my same limits of integration with it. If I can break it apart with addition, I can, of course, break it apart with subtraction. Now those two are going to be kind of important next quarter, more so than this quarter. Especially when we do integration by parts. It's going to be the most exciting thing you've ever done in your entire lives. Oh, it is. And then I can pull out a constant anytime I need to. So there's going to be times where the constant can just make stuff muddy, so I'm going to factor that out front of my integral. The other thing that I'm going to get is what we've been doing so far, is there's times in which I need to break it apart. So if I'm going from a to b and c is some number in that interval, then I can break it up from a to c and c to b, which is what we did when we were finding the total area. Okay. There's some on the homework like this where it's going to say, here's some information you need to find the evaluation. Now notice what they're asking you to do is basically either bring that coefficient out front or break up each one of these into two different pieces or three pieces. So as I take a look at A, I have an answer when I have the integral from 1 to 4 of f of x dx. Because I have that, then all I'm going to do on A is factor out the negative 3 from 1 to 4 of f of x dx. And then I know that this part is equal to this part. So I know that when I see the integral from 1 to 4 of f of x dx, I can replace it with just 8. So this is equal to, let's do it in blue, this is equal to negative 3 multiplied by 8. And then whatever that answer is. So you're going to see a couple in the homework like this. So in this section, there's a couple just like this. Now on B, I'm still going to factor that 12 out. So I'm going to factor out the 12, and I have 6 to 4 of f of x dx. And I look up there and I see I don't have a 6 to 4. I have a 1 to 6 and I have a 1 to 4. So the first thing I'm going to do is switch the limits of integration. So I'm going from 6 to 4, so I want it to go from 4 to 6. When I do that, that makes that a negative. And then I'm going from 4 to 6 of f of x dx. Now just like with the summation stuff, remember when we had our summations yesterday and I started at, say, 40 to 100? And what I did was I started from the original, I went from 1 to 100, and I subtracted off the pieces I didn't need. The same thing's going to happen here. So this is going to be equal to negative 12. Just going to put that negative 12 out there. And I'm going to integrate from 1 to 6 of f of x dx. I'm going to integrate the entire area because I have a replacement for that. And then I'm going to subtract off the part that I don't want, which is 1 to 4 of f of x dx. That's the part I don't need. So that's like what we did yesterday when we were doing the summations. Yes?
Wouldn't you do 1 to 3 because you want to include 4?
No. Because and when we're doing integration, we include each endpoint. So this integration is going from 1 to 6, and then this integration is from 1 to 4. What I'm left with, when I subtract these, I am left with an integration from 4 to 6 because it is inclusive. So I end up with negative 12, and my 1 to 6 was equal to 5.
Yeah.
And then my 1 to 4 is equal to 8. So it's negative 12, 5 minus 8. So this is equal to negative 12, 5 minus 8 is negative 3. My final answer is 36. Okay, how was that?
Sucks.
We can go back to the chain rule over there if you want. Maybe even do one of them as being a y function. Oh, that'd be great. Okay, which one of these would you like to try? Just regular integration. Just regular integration. Which one would you like to try? You want to do B? Okay.
Silently judges.
I'm not silently judging. Do B. Go ahead and integrate B, please.
So.
I'm not judging. I'm just asking. Just the starting point. This is going to be x to the third divided by 3 minus x. Just to start you on the path of integration from 0 to 2. It is, but at least we're recording. So it is 2/3 is what we get. So we also can use integration to look at comparison. So when we say that if we are integrating from a to b of our function f of x, dx is greater than 0, that means we are above the x-axis during that interval. or the summation of that is going to give you a positive number. We also can say that if my function f of x is above the function g of x, then its integration had better be a bigger number than the one that is below it. So if f of x is a curve above the g of x, then its integration had better be a larger number. So visually, here's my functions. Here's f of x. Here's g of x. F of x had better have a larger integration number in that interval from a to b, starting from, here's a, and then we'll say that's b. So from a to b. That my function on the top will have a larger integration value than the function on the bottom. We also get that if I have some m number, some output that is smaller than the function in that interval, so I can, if I have my function like this, so here's my function, say this is my function and I'm going from a to b, and if I look at my function from a to b, I can put a bound on it. So from here is m, and then from here is the big M, little m and big M. And you see I'm kind of sandwiched between there. And that gives me this. So if I take that constant m, so it's a horizontal line, multiplied by b minus a had better be a smaller number than the integration that I had. All right. So on this one, they're asking us to find whether or not this is true. How would we attack this? If this was on the homework, how would we do this? Yes? You absolutely want to multiply it through. So multiply it through and integrate. So when we multiply this through, we're going to have the integration from -2 to 3. We're going to have x squared minus x minus 6 dx. And then we're going to integrate this, and this better be a negative number. So this is going to be equal to x cubed over 3 minus x squared over 2 minus 6x. Integrated from, what was my numbers? -2 to 3. From -2 to 3. So once you integrate this, then you should get a negative number. If it's not a negative number, then it's not a true statement. So you're not guaranteed to have a true statement. You're just checking for true statements. How would you do this one? Just cry a little bit. No, how would you do this one? What are we trying to show, though? You gotta ask yourself, what are we trying to show?
Is the bound from 0 to 1 square root of 20 plus x cubed less than or equal to the other integral?
Yeah, so what would I do to show it's true?
So like 1 would go with 1. See which one's bigger?
I would just integrate and check the answer. That's it. All right, moving on. We're almost done with this section. Blowing through 10 pages today, even with a slow start. So if I want to find the average, there's going to be times in which I find the average. Then in other words, I just integrate like normal. And then I multiply that integration number by 1 over b minus a, and that'll give us the average value of the function. So if they're asking us to find the average value of the function, I'll make it so you can see that. And then all we do is we integrate x to the 5th from -1 to 1 dx. So this is going to be x to the 6th divided by 6 from -1 to 1. And then I'm also going to need to multiply by 1 over, so let me do this in a different color. So I need to multiply this by 1 over b, which is 1 minus a minus 1. So in other words, I need to also multiply this by 1/2. And that's it. It's just a constant multiplier. So we do our regular integration. So I'm going to set up the next one. So I'm going to do 1 over 2 pi minus 0, integrating from 0 to 2 pi. of the cosine of x dx, which is going to equal 1 over 2 pi. If I take and get the derivative equals cosine, what did I have to start out with? So I had to have started out with sine. So I started out with sine x. I integrate from 0 to 2 pi. And that 1/2 is just 1 over the b minus a. That's it. 1/2 is the 1 over b minus a. Okay, so let's take a look at this. Why is the integration, this is the sine 2 pi x. Why is the integration from 0 to 1 equal to 0? Why is that true? Yes?
Because it's equal in the top as it is in the bottom.
The area below is equal to the area above, and that's why it equals 0. So when you integrate, you're going to get 0. That doesn't mean that you don't have a total area. That just means your net area is 0. Yes?
And every time you have a full rotation, is that true?
Yes, every time you have a full rotation with sine and cosine, you'll cancel yourself out and get 0. All right, that's it. So there is 5.2, 10 pages in less than 50 minutes today. That never happens.